Hey guys, how are you? This video is just going to go through some info on just calculating the surface area and the volume for a triangular prism. So this is based on the assessment where we're trying to use this as like a container, and we're going to try and figure out how many items we can put in that container. So the first thing that I'm noticing that some people are doing when you're kind of writing the measurements on the triangular prism. So essentially you've got a base, which we could call A, and then we've got the two sides, okay? So if you look at this one down here, we've got that flat base, and then we've got those sides. So those sides should be the same, so we could call that surface B. So if I was to kind of represent that on here, that would be this surface here. And then we've got the triangles, which is C, which would be this part here, okay? Now, when you're coming up with your measurements, whatever you pick, the base is a certain measurement, okay? So I'm just going to make up some measurements to kind of put on here. So let's say that this measurement here might be 13. So that's going across here. And I can make a measurement for that base as well. So let's just say, I don't know, let's say 16, okay, for this kind of bit here. Actually, I won't do 16 because that makes it seem a bit bigger. Let's go 8. All right, so that's kind of what I've got there. Actually, you know what? I'm going to make the whole thing a little bit bigger. I'm going to go 18 and I'm going to go 10, going across. Now, something to consider. So if I was to work out the surface area of shape 1, or the surface area of shape A, it's going to be the base times height, which is just going to be 18 times 10, which is going to be 180 centimeters squared. So that's easy. That part's done. Now for B, for shape B, the thing to consider with a triangle is this here and this here are going to be the same. Those measurements have to be the same, all right? Because if you look at it on this shape here, this needs to meet up. So if they're not the same height, they're not going to meet up in the same fashion, all right? So whatever you pick, that needs to be the same, okay? Something else to consider, which is the main kind of issue that I've seen people have so far, is that to calculate the surface area of a triangle, it's the base of the triangle multiplied by the height. So you actually need that height measurement there, all right? So that's an important measurement to have. So what ends up happening is we need to either have this measurement and then calculate this one mathematically, or have the height measurement and calculate this measurement mathematically. So you can pick which measurement you want to come up with yourself, but you're going to have to calculate the second one mathematically, all right? Now, there's two ways you can do it. So the first way is, whoops, go back to my pen. So the first way is to draw a scale diagram, okay? Now, the way to do that is you need to draw a triangle in your book or a piece of paper with the correct measurements. So say this is 10, you have to draw a triangle that's 10 centimeters. And then you need to also draw the correct second measurement, and then you measure the third, okay? So let's say I want to give this triangle a height of 12, okay? And I want to give this triangle a height of 12. So if I was doing that on my paper, I'd draw 10 as the base, and then make sure I'm at halfway. So get my ruler and go 5 centimeters halfway, and then draw 12 up, 12 centimeters up. And then you finish the triangle with your ruler and your pencil, and you measure those sides. Now, if you're doing that in your assessment, you could have a photo of that scale diagram and attach that as an appendix for your assessment. And in your actual assessment, you can just write a scale diagram was used to calculate that third measurement, okay? And you want to be as accurate as possible. Now I'm going to show you another way to do it, which is Pythagoras, which you've probably seen before, okay? So the second way to do it is called Pythagoras, okay? So let's do some Pythag. So what we'll do is we'll draw our right angled triangle, okay? So this is where the Pythag is going to come into play. Right angle triangle. Now, what I'm representing here is I'll put it in blue on the diagram here. I'm representing this. And remember, the whole point is I'm trying to calculate this, this one here. Okay, so for this triangle, the height is 12. Oops. The height is 12, and the base, so the base of this whole triangle over here is 10. So for the right angle triangle, the base is going to be half of 10, which is 5. And this is our unknown. So I'll just put x. That's the side that we want to figure out. So for Pythagoras, the formula is c squared equals a squared plus b squared, where c is the hypotenuse, which is the longest side of the triangle. So that's this one, because it's opposite the right angle. So that's going to be c. And a and b are the remaining two sides. It doesn't matter which one's which, okay? So I might say this one's a and this one's b. Okay. So we're going to substitute into the formula. So we're going to say the x squared is equal to 12 squared plus 5 squared. So the x squared is equal to 144 plus 25, which I'll just shortcut this, and that's going to be 169. So the x is going to be equal to the square root of 169, because the opposite of squaring something is square root. So basically, to go from x squared to x, we need to do the square root of this answer up here. And the square root of 169, I know that that's 13. So in your calculator, you just have to press the square root button, and then you put 13. You just press equals, and that will pop up. So I used nice clean numbers here. Now your numbers probably won't be as clean. You're going to get decimal places and stuff like that, most likely. So just include, I would probably say 2 decimal places is what you want. Okay, so that's now 13. So now that I know that that diagonal is 13, then for my triangular prism, I know that this also has to be 13. Okay, so now I can start working out my total surface area. So the surface area for shape B on my triangular prism is going to be 13 by 18. Okay, so 13 times 18, which is, I'll just have to get my calculator and figure that out quickly because I can't do that in my head. 13 times 18, 234. And there's 2 of these. So we'll times 2 centimeters squared. So we'll just times that one by 2, and that's 468 centimeters squared. Okay, you might just want to underline each of the bits. So we've done our A and we've done our B, and now we're going to do C. So the surface area for C. Now this one's a triangle, okay? So a triangle is half base times height. So that's going to be half times by the base, which is 10, times by the height, which is 12. Not the 13, it's that 12 going up and down, okay? Times 10 times 12. So that's going to be 560 centimeters squared. And there's 2 of these. So we'll times 2. So that's going to be 120 centimeters squared. Okay. So now we've done that third bit. And now the total surface area for the triangular prism is going to be adding all 3 of those together. Okay. So 180 for that base, that A, plus the 468 for the 2 sides, the B's, plus the triangles. So that's the 120. Okay, so that's going to be 3,768. Sorry for my bad writing, centimeters squared. Okay, so that's the total surface area. But the main thing that I just wanted to show you guys is the Pythagoras. Okay, so I might just get rid of this just to clean it up a little bit. And I just want to kind of show you the Pythag. Let's say, for example, instead of this, so I'm just going to kind of change this up. So let's say you did it the other way around, and I'll do a different number now. So let's say you came up with the diagonal length. So just say you decided that it's 17. I'm just going to kind of pick another number. So you've made this one 17, okay? And now your job is to find the vertical length, okay? So let's just redo this Pythagoras, showing you the other way to do it. So we have the hypotenuse now, the longest side, and we're looking for this height here. So we need to do a slightly different rearrangement of this equation. So we still have C as the hypotenuse, we still have A and B. We can rearrange this equation to find A, which is the unknown that we're looking for. So A squared is going to be C squared take away B squared. You might remember this from last year. So this is the rearrangement of the Pythagoras. So we'll do x squared is equal to, so the C is the hypotenuse, so 17 squared, take away the 5 squared. Okay. Now 17 squared, I don't know what that is off the top of my head, 289. So x squared is equal to 289, take away 25, which is just going to be 264. So x is then going to be equal to the square root of 264. Okay, so I'm going to have to do this one in my calculator. So we'll go square root 264. Oops, you have to do it a different way in this calculator. So you go 264, then square root. So 16.25, I would round that up. So x is equal to 16.25 centimeters. So then you would label that there as 16.25. So then when you're doing the surface area of your triangle, which is half base times height, it would be half times the base of 10 times the height of 16.25. So that changes it. Now, if you ever do that, I would keep the proper number in your calculator, this big decimal here, rather than rounding it off. So then times 10 times by 0.5, and that gives you 81.24 centimeters squared. Okay, the last thing you want to look at is the volume, okay? So if we do the volume of a triangular prism, that's going to be the surface area of the triangle multiplied by the height, okay? So for this one here that I've just kind of completed, this is the surface area of the triangle, okay? That's the 81.24. And I'll multiply that by the height. Now the height, we're talking about, if you have that triangle there, it's this one here, this measurement. That's how high or how long that triangle is, okay? That triangular prism. So that's 18. So we have that times by 18. That's our volume, 1462.33. 1462.33 centimeters cubed. Okay, I hope that video helps. So that was basically looking at using Pythagoras to calculate the length of triangles, which is important to be able to do for the triangular prism. Remember, if that Pythagoras is a bit over your head, you can just draw a scale diagram on your page. Done and done. Thanks, guys. See you next time.